If you get 100 out of 100 also, there is no use. Assumptions should be satisfied, then only linear regression is applicable. Sir, if 100% accuracy is there and assumption is not satisfied, what happens, sir? Here anyways, 100% accuracy you have got now. What is your problem? Here you are going to get, but are you going to use on the past data in your permanent future also? Why you are going to do this machine learning and predictive analytics? Because we want to predict the future one. So in the future one, for example, you have done accuracy of 90 or 95%, but assumptions has failed. Yesterday, whatever the example we have done, you have used the model.predict on 200 thousands of dollars and we have got 13.98. Instead of 13.98, you have got as 15 something. And for $200, I will getting 15 and you have invested. You have invested 15, whatever the 200,000 of dollars is there, you have invested. But the answer will not be 15. The output you'll get only 12 or 11 or like that. Then what happens? Automatically it is a loss because such a huge amount you have invested and you are not getting that much of whatever the number of units to be sold, it is not getting sold, means automatically it is a loss. So our focus is in terms of real-time data. In the real world, after doing this model, whoever the client has paid for us for doing this model, once we submit the model, he has to utilize that one. That is the main purpose. So there in the real time, it has to work properly, means we have to check all the assumptions. Okay. So just for the namesake, whatever the data they have given to us, we are analyzing within the given data, we are not coming out of that data, miss, then there is no use of that. Is that clear? Now, here we are going to have scaling is done for the input variables only. Exactly. Output variable scaling should not be done. Only for the input variables. For the output variable, none of them has to be done. Okay, Leka. So for missing values, outliers, next transformations, next encoding, next scaling. So these are the 5 things are there now. All these 5 has to be applied only on the X, that is input variable. None of them you have to apply on the Y. Sir, in the Y variable, if there are outliers, what I have to do? Keep as is. Keep as is. You can't do anything. According to that only you have to work. Output variable you should not touch. That is already fixed. Answer is fixed. How to get that much of accurate, you think of that. Don't delete that, don't modify that. For example, there is a job of 10 lakhs. 10 lakhs package job is available. Now, we want to get 10 lakhs. How to get 10 lakhs, you have to think. But, sir, why they are paying only 10 lakhs? Why they are not paying 15 lakhs? You should not ask this type of question. That is already fixed. If you are interested, you join. If they are not interested, don't join. Okay, you can't change the output. Okay, the Y variable, you can't do anything. No modifications on the Y. There is outliers also, you should not do anything. So transformation, if the output variable is skewed, don't do anything. If the output variable is having with respect to categories, then it is called as classification problem and it automatically will take. The machine learning algorithms for classification model automatically will take. Okay, output variable is entirely different. Input variables are, input variable will not take. Input variable has to be encoded. Output variable, the text will be automatically considered. You don't need to worry about the output variable in the classification algorithms. In the scaling also should be done only on the input variable, no output variable. Don't touch the output variable. Sir, in the output variable, if missing values are there, you told from outliers, transformations, encoding and scaling. These 4 you'd have told. What about missing values? If in the output variable, missing values are there, you drop that particular row. Drop that particular row. Don't replace the values. For example, 1 is there, 2 is there, 3 is there, 4 is there. And next number, you are only writing and you are only predicting your answer. You are writing the answer and you are only predicting your answer. What is this? Actual answer is yours. Predicted answer is also yours. Actual answer should be given by the data. Predicted answer should be matched to that data. Don't replace the missing values. You have to drop them. The only in the output variable, whatever the things you have to do is drop the missing values, nothing else. Don't touch the output variable. Try to match to the maximum extent to get with respect to that. Is that clear? Right? Now, let's move on to the next one. Now, sir, that business problem understanding. For example, now the question is, sir, for earlier you told that don't do scaling on the output. Okay. For example, output is 10. Okay. I got the beta naught value as 4. X value is 4. X value is 4. Now the beta naught has been calculated as 2.5. Okay, fine, sir. Done. Now you told that do the scaling on the X variable. On the X variable, you asked me to do the scaling. So X value is 4. I am doing the scaling. Now automatically once it is scaled, let us assume it has got to 0.4. Now if I multiply with the same 2.5, answer is going to be 1 and large difference will be there. Na? So once you do the scaling, automatically this value will be converted to 25. This value automatically will be converted. The beta naught will be converted to 25. So 25 into 0.4. Now again it is going to be 10. If one value is scaled, automatically beta naught value increases. Okay. So if you want, you can try. You can try after the class. See, the problem with the students is, what is the problem is, just we are going to explain one example. We'll explain with one example. That too very simple example by considering some randomly some numbers of x comma y and taking 5 values like this. This I will do generally. Okay. By listening this self, they'll understand that, oh, I have understand everything, and they will try to apply on the 30,000 rows. They will learn only 5 rows. They will try to apply on the 30,000 rows at a time. They feel that they have understand everything and they want to check themselves and they want to prove that they are tops. Some kind of. At the end, they will not understand anything. They will only confuse. Again, they will come with the questions. Of course, I will answer, again confuse, again answer, again confuse. This confusion will continue like that permanently. At the end, who is going to lose miss? You only. For me, nothing. For me, nothing. At the end, it is not going to affect for me anything because I am going to give the answers. Whatever the questions you are asking, I am giving the answers. Na? So then what I have to do, sir? Then in the linear regression, whatever the example you have considered, earlier you have taken some values of x. Na? Do the scaling for the same x values. Without touching the y values, do the scaling for x values. And try to apply the simple linear regression on the same example, whatever we have discussed with a simple example, manual calculation we have done. Na? Do the same. You are not having that much of interest to do that one. Because by listening first time itself, we have got to understand everything. Na? Directly we want to apply on the large amount of data. And we want to check ourselves. Happily you can do. Happily you can get confused of yourself. No problem for me. Absolutely. If you want to learn the subject, that is not the way. You want to see how the scaling is going to affect on the y variable, miss? Take the small data set and check yourself without scaling and with scaling. Without scaling, do manual. I have done in the class manual calculation step by step. Na? Calculated x bar value, x minus x bar value. I calculated for every record and I have done everything manual calculation, right? You can't do the same thing in your notes, right? That much of patience is not there. That much of interest is not there. That much of things are not there. But full of greediness is there. That to get a huge package. So at the end, who is going to lose miss? It's off. If you understand this example, change yourself. If you are not, no sir, this is not the right way. Whatever we are following is the right way only, miss. Happily continue. Absolutely no problem. This is only a suggestion. Not mandatory. Okay. Happily do whatever the things you want. Enjoy. Right? So absolutely for me, no problem. The only thing is to want to learn the subject, miss, directly going and applying on 200 records, 500 records, how you will understand the concepts? When you want to understand the concept or you want to apply the concept, which one? First, get the clarity. You want to learn or you want to apply? Learning is different, applying is different. While applying, learning is not possible. Automatic confusion only is possible. Okay. No, sir, while application only, learning is possible. If you feel miss, continue the same. Absolutely no problem. Once again, I'm saying. Your motto is the same, miss, continue. Okay, I have observed that one. In multiple students, I have observed that one, not with one student. I'm not going to say about one student or name of the student or nothing like that. I have observed multiple students. You are going to send me the message only one student is sending. You feel that you are sending, but in your class itself, so many people are sending for me. Right? So many people are asking different questions. Okay, not only this, multiple batches. Whatever the batches I'm having, every batch. Right? The student will think that I'm only asking the question, but multiple students are asking different way, different questions, but at the end, the same thing. What is the question they are asking, which we have to discuss in the future, that they are asking. And what is the thing they have to know, while application they want to learn. Future scaling, they want to see the application after applying to 200 records. Yeah, for 5 records, future scaling difference you can't see. It says that I will not show. For 5 records or 2 records or 3 records, you try without future scaling and after future scaling. What happens? The difference you will observe. Is that clear? That is called as practice. Right? So make sure. And today's class, once I will explain again, after this class immediately, sir, I have got a Kaggle data set, sir, and I want to apply. Happily apply. While applying, again, you will get the doubts, I will clarify them. Again, you will ask doubt. Again, I will clarify. At the end, I will get the subject. You will be in the same confusion state forever. If you want, you can try. If you want, you can try. Please try. After this class, immediately the moment it is complete, try with a new data set by taking one of the data set from Kaggle. Confuse. Happily, you can get confused. And at the end, after some days, 10 days or 15 days after, sir, your concepts are very clear, sir, but I'm forgetting, sir. Because your learning is different now, sir. Obviously, you'll forget. Your way of pattern is learning is different, For temporary purpose and that position purpose, for that particular example purpose, you are learning. You are not learning for generalized purpose, Automatical confusion only will be there. You are learning generalized purpose means, for every project, the same thing will be there. Everywhere you can apply. For that example, what is the answer you want to know? At the end, what will happen? Forget only will happen. Sir, this much of syllabus, sir, I'm forgetting, sir. You have not practiced means obviously you'll forget. Yours is Einstein brain, to remember all the things. Not right? So we know what is our level. I'm not going to degrade you, or I'm not going to say in a light way like that. But understand what is your capacity of your brain. And according to that, you work. First, understand yourself. Right? So, for example, if I am I will learn from one trainer. If I'm not able to understand this, again, I will learn from one more trainer. Again, one more material. I will try like that. Because one example will not satisfy me. This is my brain. Some brains, something. Each person is a different. I'm not saying, I'm not comparing to everyone like me only. I'm not comparing to anyone. Every one person is a unique person. According to you, you have to make sure how to practice yourself, which makes of practice makes you perfect. There will be one topic, one topic you have perfect in your brain. One topic is very perfect. Which topic is perfect? You will understand, right? Write the topic name. This topic I am very perfect. 100% out of 100. Okay. Then how you have got that much of 100% for that particular topic? Just write the steps. What are the steps involved in that? How to get that 100% perfectness? Apply the same steps in another topic also. That is deep learning techniques. Artificial intelligence techniques will work on the same concept. If you want, you can write. in your notes right now. Sir has told like this. In the deep learning algorithms will come now. Then at that time you'll understand what is the concept. Deep learning means detailed learning. Learning very detailedly, step by step, in depth is called as deep learning. Deep learning algorithms you have to understand means you have to focus in that way. If you focus in this way, automatically confusion will leave. Because I'm saying all these things, still you are in the starting stage of machine learning. Total 25 algorithms are there, out of which only one has been completed. Still 24 are there. If I say at least now, you'll change yourself. That is the reason I'm explaining all these things. Okay, my motto is not to waste my time. If I complete means for me only, I will get the salary too early. Okay, I know this almost 20 minutes I'm taking extra class, but this 20 minutes will make you the difference to preparation. I assume. My null hypothesis. Right? So, whatever the learning concepts you want, take with a simple example. Application concept you want, take with a big example. With the application you want to learn, get the confusion. Okay. So without confusion, I want to learn application by learning the application only I want to get, but without confusion, sir, miss, it is not practically possible. If you are asking like, sir, I want to walk and I want to reach the moon, miss, you are asking like that. Walking is there, moon is there, both are there, na? But both cannot be combined. To my knowledge, to my things, whatever the experience I am having, my personal experience or with respect to the student experience, whatever I have seen, I have never observed the student while application they are learning. Learning is a different part, application is a different part. Okay. Sir, while learning, make with a simple example and check the difference. Sir, outlier is there. What happens on the linear regression? Take the same 5 examples. Whatever the example you have done, in the class, 5 numbers you have taken for X and 5 numbers you have taken for Y. Na? Out of which one of the number is 10 is there. Na? Instead of 10, take 100. Do the calculation once again. Practice. Now, sir, if there is a missing value here, what I have to do? With missing value, again apply the linear regression and check what happens. Same data fit with X train and Y train. I have shown you the simple example also, the concept how to build the model. With the simple example also, I have explained the building the model. That is on the Friday class. You apply with missing value and you will get the error. When you fit with missing value on the X variable and if you fit on the linear regression with X train, comma Y train, you will get an error. Linear regression will not accept the missing values. Whereas decision tree, random forest, advanced algorithms are there. They'll accept the missing values also. Whether they are going to accept or not, miss, first you try with a small example. Like this, you try with everything. Missing values you try, one outlier you take and out try. Outlier you keep in the Y and try. Outlier you keep in X and try. And write the notes. Automatically, when you try these many times for different types of things, examples, which you have developed of your own, automatically subject level will be increased. Because within this five, whatever the 5 records you have taken, in this only I'm making 10 different examples I'm making, 10 times I'm applying, 10 times I'm writing the formula, 10 times I'm doing the manual calculation, automatically brain will register everything. Concept will be registered, brain will register everything. But where's our practice time that much of? To write Instagram stories, we have time. To see the Instagram reels, we have time. To go on WhatsApp, we'll have time. Right? To go to movies, we'll have time. But for practice, we'll not have time. For attending interviews also, we have time. Without having the subject, attending for multiple interviews also, we have time. We have time for begging also others. Please give the reference. In your company, there is a opening. For begging also, we are having time. For practice, no time. Getting the point? So please work accordingly. Okay, by single shot, sometimes we're not able to understand, miss, try with the multiple things. And that too, don't apply on the large amount of data set immediately if you want to learn. Sir, I have learned, sir, but now I want to apply and I want to check my result. Apply on the large data. Don't apply on the small data. Is that clear, guys? It's true. Practice, no time. So that is the reason. If practice, no time is job also no time. Answer is very simple. If anyone without practice, sir, I have not done any practice, sir, by listening your class, sir. Just every day I'm coming and I have paid 15,000 in the Naresh IT. Every day I'm attending your class from 8:30 to 10. Of course, 8:30, it is 8:40. None of the day it is started at 8:30. We know that. 8:40. 8:40 to 10 or 10:05 or 10:10, something like this. So every day we are sitting in the class and we are listening, sir. Now, after listening, I have got the job. If anyone says like this, first I will book the Ravindra Bharati for doing the first session. Second thing, I will say about you in every batch to every student. Third thing, I will refund your fees also because you are a great person. Okay, that too for booking Ravindra Bharati only 10 lakhs. For your fees, 15,000 only. For me, 10 lakhs, 15,000. No problem. Okay. So if you get the job, miss, please let me know. Right? Clear, guys? So with practice only you will get. And number of textbooks I have already uploaded in the drive. What are the textbooks I have already uploaded in the drive? That is the thing I have shown you. And along with that, I have shown you how to get the textbooks also. How to get multiple textbooks and how to download them by using LibGen. That is LibraryGen. LIBJGEN. Just type and you are going to get from here and type machine learning or whatever the word you want. And you will get number of textbooks you will get. Right, guys? So let's start this multiple linear regression. So first we are going to apply the concept of, first we are going to load the data. Now after loading, importing the libraries, I'm going to load the data set. And in this data set, already the same data set, whatever we have applied, TV, radio, newspaper, the same data set, once again, I'm going to load. And here, if you understand the data, it is the same data, whatever we have applied, the same data. And if you go into the info, the same info, just give me, guys, it is going to take 2 times. Okay, first I'm going to import the libraries. Next I'm going to import the data set. I'm going to load the data set. Shit. 1 minute. Just give me a minute. I'm closing off all the kernels. Somewhere some mistake is there. Yeah. Just a minute. Okay. So first I'm going to load the libraries and I'm going to load the data set. Yes, it is now perfect. So once I load the data set, now I'm going to check the data set and info. This is the old one, the same, whatever we have discussed yesterday morning only, the same thing. And is there any missing values? Miss? There is no missing values, the same thing. And here you are going to use the describe function and pair plot. The same thing, whatever I have done in the previous class, as it is, I'm going to do nothing. For the EDI, there is no difference. Now, only difference is, yesterday we have done the relation between the total spend versus sale. Now, this time we are going to work on the, what is the relation between each advertising channel versus sale. That is, y hat is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Here I am having three variables. The first variable is x1 is TV. The second variable is radio. And the third variable is newspaper. The same, whatever the x1, x2 and x3, whatever the order you are going to give in the input of x, you are going to write here x is equal to consider like this. Na? Here you are going to write here. This, whatever the x variable you are writing, the same order it is going to consider. The x1 is going to be in the same order, whatever you are giving in this x. You are assigning to x variable, na? The same thing it is going to have. So here, if you observe the pair plot, I want to observe this only, this one, this down part only, because this is my y variable. On y-axis, I want my output versus x1, output versus x2, output versus x3. So this is the scatter plot which I have to observe. Out of which this is having the linear. Okay, somewhat linear, fine. But this is having with respect to, okay, this is also linear to some extent. But the distance between the data points is large. Means the correlation will be somewhat low. Here the correlation is somewhat high comparatively. And if you observe here, there is no relation. There is no linearity. You can't draw a linear like this. So if you observe the correlation quotient matrix, here we can observe that clearly that sales versus TV is having a correlation. This is the last line which I want to observe. Because my output variable is this one, x1, x2 and x3. So y versus x1, 0.78, which is a good. Y versus x2, which is also a good moderate correlation. Y versus x3, 0.22, which is a low correlation. Okay. So we can clearly observe that if the data points are far, means the correlation is low. If the data points are less far, means the correlation is like this. If the data points are somewhat tight, means the correlation. As the data points more the close, the correlation is higher the correlation. Right? The relation between y and x should be high. The higher the value, the stronger the correlation. Between y and x, it should be high. The relation between any two independent variables should be low. Now you have to check between x1 versus x2. It is 0.05, low only. x1 versus x3, again 0.5 only, not a problem. x2 versus x3, 0.35. So this is also okay. So if you observe, the correlation matrix is having the upper triangle matrix and lower triangle matrix is same. Because x1 versus x2 and x2 versus x1 will be the same. The relation between the same. Now, here, the relation between any two independent variables should be low. For example, if the correlation between any two independent variables is strong, then it is called as collinearity problem. Okay, collinearity problem. So in my case, there is no collinearity problem. There is no strongness. There is no collinearity problem. Happy. It is okay. Now, first what I am going to do is considering the x variable. The x is nothing but dropping the sales column. After dropping the sales column, what are the remaining three columns are there? Should be considered as x. The sales column should be considered as y. If I open this x variable, TV, radio and newspaper. These are the three columns will be considered. Out of which one is x1 and which is x2 and which is x3 miss? This is x1 corresponding beta 1. This is x2 corresponding beta 2. This is x3 corresponding is beta 3. Now whatever the beta 1 you have got, that is related to TV. Beta 1 value is not related to radio. Beta 1 value is related to TV. So now what I'm going to do is train test split. I'm going to apply the 70-30 ratio train test split with a random state of 42. After applying this, now I'm going to do the modeling, where the modeling consists of y hat is equal to beta naught plus beta 1 x1, that is TV, beta 2 into radio, beta 3 into newspaper. So now, first, what are the three steps involved in modeling is import, save and fit. So I'm going to import the linear regression and I'm going to save into a model name and I'm going to fit on the x train and y train. Now, model dot intercept value, that is beta naught. You are going to get the beta naught value, which is 2.7. Model dot coefficients, which is nothing but slope values, that is beta 1, beta 2 and beta 3. This is the beta 1 and this is the beta 2 and this is the beta 3. So now the equation is ready. This is the best equation for the given data applying the linear regression. That too for given data. The word of given data is important. If the data changes, values changes. For example, you have treated the outliers. You have removed the outliers. Automatically data changes, right? So data change means automatically values will change. Whatever the given data, according to that, the equation will be formed. Right? So here, based on the given data, the equation is beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Right? Now, sir, you are fast, please. The same thing now. That is the reason. I have explained anything. I have told you new thing today. If anything new is there, miss, please let me know. Which part I have told new one, so that I will explain clearly on that. Which part I am saying the new one first time? For the first time I am saying this one, sir. Is there anything like that? In the simple linear regression, I have imported the data libraries I have imported, followed by data I have loaded. Automatically I have done the with respect to info, missing values, followed by EDA, same pair plot. Everything I have done in the simple linear regression. Yesterday only I have done. Na? Yesterday only I have done. Right? So that is the reason I am applying somewhat fast. I am moving somewhat fast. If I am applying for the first time, if I am explaining this, then I used to explain. Can you explain with a missing value in the data set? If there is a missing value, Mamata, you have to replace the missing values. If it is less number of missing values are there, replace. If more number of missing values are there, replace with mean or median or mode. Have you attended the class with how to deal the missing values? Treatment of missing values? Yes, apply the same concept here. If there is a missing values, apply the same concept. Right? Now, here I am going to fit with respect to the data. After fitting, what you have to do? In yesterday's class, what we have done after fitting? Prediction. So you are going to do on the model.predict on the extend, model.predict on the xtext. After prediction is done, what is the thing you have done yesterday? In the previous class, what you have done? Modeling of 3 steps we have done, prediction of 2 steps we have done. After that, evaluation. So we have evaluated. Same thing I am going to do. I am going to calculate the RMSE only. Mean absolute error or mean square error, no need to calculate. Directly we enter into the RMSE. Let us calculate the RMSE values. So this is the train RMSE and this is the test RMSE. Next, model.score with respect to R square, train R square and test R square. One is 90% and one is 86%. Means from this what we can conclude that it is not a overfitting problem. So checklist 1. Whether the model has overfitting or underfitting problem. Answer is no. It is a good model. It is not having either overfitting or underfitting because the range is plus or minus 5% only. So which is acceptable range. So there is no problem. Okay. Now next what is the checklist we have done? Test accuracy is equal to cross validation score or not. The same thing I am going to do. Once again. And I have got 88. This 88 is equal to test accuracy. What is the test accuracy I have got? 86. 86 and 88. Almost close. Again, it is almost close. So no problem. So this is also perfect. Nice. What is the third checklist we have to do? For the linear regression, you have to do the linear assumptions check. So check the assumptions. For checking the assumptions, what are the assumptions? 1, linearity of errors. So independent of errors. Next one is normality of errors. Next, equal variance of errors. Now you are going to do the errors. First, you are going to identify the errors. What we have done in the simple linear regression, the same thing, guys. Copy paste I have done. Copy paste only I have done. Just in another notebook, I am explaining new algorithm. So I have taken a different notebook. If I am a working person, I used to do in everything in one notebook only. Since I am a trainer, my job role is as a trainer. So I want to explain each algorithm separately. So I have taken separately. So yesterday linear regression, whatever the simple linear regression I have done, step-by-step process, copy paste I have done. I only copied and I only pasted. Nothing difference I have made. The same thing I have copied done there. And the same steps as it is will be there. Prediction will be there, errors will be there, as it is will be there. Right? Now, here you are going to calculate the errors, and after the errors, you are going to check the linearity of errors. Now, if you observe the linearity, it is not having with respect to like this. If you draw a line, this is linear means within this only it should be there. Here you can have more number of data. Okay. Next, normality. Let us go with normality. If you check the normality, can you observe? It is a skewed, it is not normal. Whereas yesterday's one, the same example in the yesterday's class with respect to normal distribution. In the today's class, it is a skewed distribution. Can you observe clearly? Sir, I want to check the skewness value. Go and check the skewness, dot skew. Either if it is this clearly it is not visible for you, miss, check the skewness. Both will give the same answer. There is no difference. So here we can identify that the data is not normal. That is, errors are not normally distributed. Miss, linear assumption has one of the assumption failed, also fail only. Next, we are going to check the homoscedasticity. That is equal variance. In the yesterday's class, we have checked the whether the errors are equally having the variance of equal or not. That is, almost every value is below the 6 and this one. Only one value is having this side and this side. So that is not a problem, but most of the values are between the plus and minus 6 only, the range of plus and minus 6. Now let us observe this one today. The same thing, copy paste, the code is copy paste. Now above side, I am having maximum of 2 value. Below side, I am having the maximum value of like this. More number of data points are lying here. Can you observe? Means it is unequal variance. Unequal variance of errors, which is a heteroscedasticity. This particular example is having the problem of heteroscedasticity. If the heteroscedasticity problem is there, then linear regression is not the best fit one. So now we are going to do the same variance significance. Actually, I have told you that variance significance for each independent variable, the corresponding beta naught is equal to 0. So for x1, PV beta 1 is equal to 0, not equal to 0. For radio, beta 2 is equal to 0, beta 2 is not equal to 0. This is null hypothesis, this is alternate hypothesis. For newspaper, beta 3 is equal to 0, beta 3 is not equal to 0. Based on the p-value, either we are going to accept this one or this one. Now let us go and fit on the, again I'm going to apply the OLS technique. Whatever I have done in the last class, the same thing. Copy, paste once again. No change in the code. Okay, I'm going to just do the same thing. Now, if you observe here, the x1, this is the beta naught. Keep the beta naught aside. No, there is no problem with the beta naught. Now, beta 1 is p-value. P-value is less than 0.05. P low, null go. Means reject the null hypothesis. Beta 1 is having certain value. Means in your y hat is equal to beta naught plus beta 1 x. Some beta value is there. Next, p-value of this one. Again, p-value is less than 0.05. P low, null go. That is reject this one. Accept beta 2 is not equal to 0. Means write the equation with respect to x2 also. Next, p-value is greater than 0.05. P high, null fly. Means states that beta 3 is equal to 0. What is meant by beta 3 is equal to 0? Means something into 0. Means this variable is not having impact. Please delete this variable. It is saying in that way. That is the reason your linear regression assumptions has not met, because this is not satisfying the condition. If one of the variable is having like this, it is not going to satisfy. Here it is applying one sample t-test. Just it is going to work on the one sample t-test, and this is the test statistic value and this is the corresponding p-value. And since it is a two-tailed test, it is applying with respect to two sides. That side, any value is less than 2, this also is error, and it is rejecting the null hypothesis. Any value is greater than this also, it is rejecting the null hypothesis. Since this value is less than this side, so if left side value lesser than this value of test statistic will be rejected. So this value is less than any value less than this will be rejected. See, 0.17 is less than the minus 0.013. Automatically it is less than that. So that is the reason it is getting rejected. Any value is greater than this side will be rejected. Right? So now here with respect to we are having this p-value based on the p-value, simply to understand p-value. So we have done all the hypothesis testing only based on the p-value. Now, just observe the p-value only. P high, null fly, P low, null go. For every individual variable, you are having the null and alternate hypothesis like this. Overall ANOVA test is overall testing. ANOVA test is overall. But whereas this one, with respect to this one of the variable has failed. Since one of the variable has failed, that is the reason some of the data points you are having like this. Why unequal variance you have observed here is due to that. Remove that variable and observe, try once again. You'll have every values will be between plus and minus 2 range. Equal variance you'll observe. Since that particular variable is not significant, that is impacting the entire linear regression. Now, one way is you have to leave this model, linear regression model, and you have to proceed with the next algorithm. For linear regression, it is not able to fit. Now, whatever I have done is baseline model. You are going to rectify the outliers or anything you are there, and you are going to try and you are going to improve. And still, after trying the missing values and after trying the outliers, after trying the distributions and everything I have tried and I have done perfectly, sir, and I have kept miss. Whatever the maximum you are going to do, after doing that also, still the variable is not significant, then the only option is you have to drop. But the question is, sir, out of the data, x1, x2, x3, if one of the column is dropped, what happens, miss? 1/3 of the columns you are dropping, miss 33% of the data you are dropping. 33% of the data you want to drop, more than 5%, miss, you have to statistically prove. Less than 5% of the data, you don't need to prove anyone. Happily, you can delete it. Sir, I'm not interested. I have deleted. Okay. Why you have deleted? No one is going to ask. For example, in this class, one of the student is doing some kind of nonsense work or he is disturbing the class. If I ask that student to get out, miss, the admin is not going to ask me that why you have sent this student outside. If I send a batch of 10 students outside, miss, then they will ask me. The same question they will ask me, sir, why you are sending 10 students outside? Right? For one student, they will not even question me. Means less than 5% of the data, you no need to explain, you no need to prove anything, nothing. But if you want to remove more than 5% of the data, statistically you have to prove. So here, if I want to remove this x3 variable, I'm proving that this is not significant. By applying the hypothesis test, I'm saying this particular variable is not significant for predicting the output variable. Statistically, it is proved. Now, without removing this column, is there any other possibility? Dropping the column, everyone will do. Till this, other trainers will explain for you. Till this part, other trainers will explain and they will say to drop. But without dropping, can you do anything else? Within the linear regression. Within linear regression and without dropping. For the baseline model only. Again, not doing the fusion engineering also. Still you can do. Means, yes. First, I'm going to try any particular value is influencing. Any particular value is influencing the data. I want to check the influence of any particular record. For checking that influence, I'm going to use the import statsmodel.api. This is the library. I'm going to import as SM. In this, there is an option called as graphics. In that, influential plot is there. Okay. You take this influential plot and keep the model name. And once you keep this model name into this, it is going to give us influential plot. Means each record, how much the influence it having on the particular model. For example, in this class, I'm having 40 students in online and 40 students in offline. Okay. Now, whoever the students, okay, let us go with only offline students. 40 students who are having in offline. Now, if one of the student is influencing others, for example, he don't want to go to the class today and he wants to go to the movie, some movie. Now, instead of he is going to absent, he will ask entire class, "Arey, let us go to the movie. Let us have a mass bunk." So in our college days, we used to have we'll do some kind of mass bunk, right? So at that time, only one student or two students is going to influence the entire class. That students are called as influential students. Similarly, here also we are having some influential records, which is going to influence more. Which record is going to influence more means 130th record is going to influence more. This is the index numbers, which is having that larger the circle, the more the influence it is having. 130th record is having more influence, it seems. And with respect to this fifth record, 165 record, these are having with respect to high influence. So let us observe what is this 130th record by using iLog. I am using iLog and observing the 130th record. If I observe, it is saying that TV is having less and the radio is having more. Generally, TV will have more and radio will have less. Na? Here, TV is having very less and radio is having 30 to 40 times more. So that is the reason this particular record getting influenced on the model. What I'm going to do is I'm going to remove only this row. If I remove only this row, what happens? Earlier, I'm having X1, X2 and X3. So each column consists of 200 records, 200 records, 200 records. Total 600 values you are having. If you remove in that 200 records, if you remove means remaining you will be having only 400. If you remove one of the column, if you remove newspaper column, the third column if you remove, you are going to have only 400 values. Net you are going to have 400 values. If you check the 400 divided by 600, it is 66% of the data only you are working. If you remove one column is. Now what I'm going to do is, out of 600 values, I'm going to remove only 3 values. One record you are removing means only 3 values you are removing. If you count values means in the TV 1 value, in the radio 1 value and in the newspaper 1 value. Value wise 111. 3 values only you are going to remove. Which is still 597 values you are working. 597 divided by 600 if you take, which is almost 98% or 99%. Just you are removing just 1% or 2% of the data. By removing this, can we improve the accuracy? I want to see that one. So let us try. So I'm going to drop the 130th record. The 130th record is dropped and remaining only I'm having only 199 rows. And again, I'm going to fit on the data with the new data, df underscore new. This time data is called not df underscore new. What is meant by df underscore new means which is dropped the index of 130th record. That record only is dropped. Record means both input and output. Automatically output also will be dropped. Right? Now if you observe the p-value, earlier it is 0.86. Now it is 0.43. But still it is not significant only. Still it is not significant. But value has been reduced. Now, one more way is variance inflation factor, VIF. This is one of the interview question. What is VIF? VIF is nothing but VIF value is given as 1 divided by 1 minus R square. This is the formula for VIF. 1 divided by 1 minus R square. Sir, what is this? Okay, don't write the formula. Understand the concept of that. What is this VIF means? VIF, we are going to check how much one independent variable affecting other independent variables. One independent variable, one input variable. Okay, guys, let me write. First, let me complete my writing, then you can write. Because what is the sentence I'm going to write, I also don't know. Just give me a minute. Okay, how one input variable is going to affect the other input variable, affects the other input, all the input variables. Now what we are going to do is, here we are having x1, x2 and x3, 3 variables are there. I want to check how x1 is having the impact on x2 plus x3. Now this x1 I am considering as the y variable. Remaining 2 I am considering as the input variables. I want to see the relation between x1 versus x2 plus x3. Similarly, x2 over x1 plus x3. Similarly, x3 over x2 plus x1. I want to check one over others. Is one is dominating others or one is not dominating others? I want to see that one. Okay. So that indirectly I'm again checking the with respect to the influence only. But this time the influence I'm not going to check on the output variable. Earlier the influence whatever I have checked is on the model. Model means how the influence of x1 and x2, x3 is having over the y. Right? This time I'm checking between the independent variables. That too, variance wise. What is variance formula? Which is nothing but x minus x bar whole square divided by n minus 1. Divided by one more variable. This is x1 variable means with respect to x2 variable. Automatically, which is nothing but, if you cancel, it is nothing but R square formula only, right? Out of which one is having the influence of others means automatically it will be the predicted value only. Automatically it is R square value. So that is the reason you have got 1 divided by 1 minus R square. R square says the variance, change in the variance, quotient of variation, right? So here I'm going to apply the same thing. See, radio on newspaper and TV on the radio and newspaper. Here the TV is considered as the y variable and x1 plus x2. So here x1 over x2 plus x3. This is the first one I am going to apply. After that I am going to apply x2 over x1 plus x3. Similarly, I am going to apply x3 over x1 plus x2. These three things I am going to apply separately. First thing I am going to apply over x1 over x2 plus x3. And I want to check how much this influencing other. Let me check. And I have fit with respect to the data and I am going to take the summary. In the summary, I have got R square value is 0.005. No impact. It is not impacting. R square is very low, na? R square is very low means variation is very low. Variation is low means there is no impact. Right? So R square is low. Sorry? Yes, the entire data I have taken. Yeah, well, without removing that, I am showing. That is one option. By removing the influential plot, we can get, I am seeing that one. By VF, I can get or not, I am saying that one. Each one of independent. Independent testing. Separately, I am checking with each one. Is any possibility is there? With that possibility is there or this possibility is there, this possibility is there, like this I am trying. If none of the possibilities are there, finally I will remove only. I will try my max. After trying all these things also, if I am not able to identify, I will simply remove only. Statistically, I have proved everything means I will remove. Right? Now, here, if I am fitting on the, and I am calculating the R square value. So, whatever the R square value I have got, this R square value will be taken and VIF of TV is equal to 1 divided by 1 minus 0.005 whole square. Okay. And you are going to apply this one and you are going to get the VIF value. Now, VIF value of TV, radio and newspaper. Three things I am going to take. VIF of TV, VIF of radio and VIF of newspaper. Which is nothing but 1 minus R square of TV. Whatever you have got here R square value, that you are going to save it here and you are going to calculate the VIF of TV. Getting the point? If you want to explain, once again, I'll explain. See, SMF dot OLS TV over radio plus newspaper. The same thing what I have applied above from here to here. Now, here, just in front of you, I'm again copying the same thing, guys. Okay, copy. And I'm going to do paste here. Okay, now whatever the fit is there, now the model is going to save here. Since I have applied the fit, the model is saved. If I use dot R square, now this is going to save the R square value. So let us observe. Let us observe this one. See, R square value have saved, which is nothing but the same value, which is 0.005. Right? The same R square value stored. So if you write R square means R square value will be stored. If you don't write R square, model will be stored. If you ask like this, model, linear model has been stored. If you want R square means dot R square value will be stored. Is that clear? Up to right, if you write only up to fit means model will be stored. It is the model. Model will be prepared on the right side and the model is going to be stored on the left side. The whatever the variable you have assigned. If you have taken the dot R squared, you have written this one means what is the meaning is after doing the fitting, calculate the R square value. Whatever the R square value you have got, after doing the entire right thing, now you save it in the left side. First right side part has to be executed, followed by left side. So first up to R square also it will calculate, and after calculating that R square value, now it is going to store in this variable that R square value. R square value will be stored. So like this, I'm going to store first R square value with respect to the TV, and this line saves for me R square of TV, and this is VIF of TV. That is 1 divided by 1 minus R square of TV. I'm going to substitute here, and I'm going to get VIF of TV. Similarly, this one, R square of radio, R square of radio, and I'm going to calculate VIF of radio. Similarly, I'm going to calculate R square of newspaper, and similarly VIF of newspaper. These three things I'm calculating. Now, once I have calculated the three things, I'm storing in the each variable. Three variables, three values has been stored. Using these three variables, I'm going to create the data frame by using the dictionary. These are the variable names, and this is the VIF. So once you create the data frame, automatically this will be considered as the column name, and this is the values. So variables, you are going to get variables TV, radio, and newspaper. Heading as VIF, and first value, this value will be stored here. This value will be stored here, and this value will be stored here. You are going to get like these three values. I already explained you how to create the data frame using a dictionary in the pandas. Right? The values. Dictionary will consist of key, value, where the value is a list of values. The same example I have taken in the pandas. If you remember in the pandas how to create the data frame, this code will be automatically easy. Otherwise, you will feel this one as a new one. You will think that it is a new one, some new code I have written. Nothing new code is there. Just I am creating the variables along with the values and a data frame. So for this, first I have to execute this one. And after that, I have to execute. Now I have got the VIF values. Now any VIF value is greater than 4. That particular variable is having the more influence on other variables. But here, all the values are less than 4 only. All the values are less than 4. Means it is saying that it is not impacting other variables. One variable is not impacting the other variables. Every variable is a good variable as per VIF. Okay, next. AV plot. Third option is AV plot. One is influential plot. Second one is variable VIF, and now AV plot. AV plot means added variable plot. Now, what is added variable plot means? Now, till now we have done the differentiation like this. From where you got this linear regression concept? OLS technique. What is meant by OLS technique? SSE to be minimum. What is the meaning of SSE? Sigma of y minus y hat whole square. This value should be minimum, right? This value should be minimum. How you have got this one? Sigma y minus y hat whole square. This value should be minimum. What is the meaning of that? Sigma of y minus beta naught minus beta 1 x1 minus beta 2 x2 beta 3 x3. In our case, three variables are there. So this is the equation, whole square. This should be minimum. What is meant by minimum? D by dx. Calculate the d by dx is the minimum. Applying the differentiation is called as calculating the differentiation. Applying the differentiation and x at x is equal to 0 is called as minimum point, right? Now, in order to calculate, we are going to apply the d by dx, which I have explained in the simple linear regression theory part. Now, instead of going with d by dx, I am going with dou by dou x. What is meant by dou by dou x means partial differentiation. What is meant by partial differentiation? What is the meaning of partial differentiation? Partial differentiation means, if you are not remember this partial differentiation, no worries. I am going to explain clearly. Just focus. So partial differentiation is nothing but when we are working, when we do apply partial differentiation on one variable, the other variables will be constant. So for example, if you are applying dou by dou x of x1 means only x1 will be there, x2, x3 will remain as it is. No variation in the x2 and x3. If you are applying dou by dou x2 means x2 will change, but x1 and x3 will constant. And if you are applying dou by x3 means x3 will change, but differentiation means whatever the differentiation you are applying on the single variable, the other variables are not going to affect. The other variables will be constant. It is going to apply only on the single variable. Differentiation is called as partial differentiation. And here I am going to apply the same concept of partial differentiation instead of going with the normal differentiation. And I'm going to apply the same thing, and I'm going to take sm.graphics plot part regression grid is the function, and I'm going to give the model name. Once I give the model name, now if you observe the plot, here, can you clearly see that TV is having a slope like this, a curve with a slope is there now? Some slope is there now? Can you observe for the radio? Again, is like this, but for the newspaper, if you observe, it is a horizontal line. What is meant by horizontal line? What is for horizontal line? What is the slope value? 0. Means it indicates that this value is automatically 0. Partial differentiation also says that this particular variable is not having any impact. Please remove this one. I got a confirmation from hypothesis test. I have got a confirmation from partial differentiation also. That is linear regression test. These both tells us remove the variable of beta, that third one, which is newspaper. Because beta 3 is equal to 0 means indicates that whatever the value you are going to multiply with x3, it is going to be 0 only. Any value, if you keep 10 lakhs also, it is 0 only. 10,000 also 0 only. 1 also 0 only. Whatever the x value, the particular variable is having 0. So that is the reason I'm going to drop this particular column. So finally, I'm going to make the model with only TV and radio, the dropping of newspaper. So to drop one column, you have to prove this much. Statistically, you have to prove, then only you are eligible to remove the more than 5% of the data. Now, finally, we are going to do with respect to only TV radio by considering only TV radio. Yes, exactly, Satyanarayana. This is the statistical way of proving. Statistical way and mathematical way. Okay. So from here, finally, if you observe, all the variables are significant and the R-square value also very good. And this one also, ANOVA test also satisfied. Now, this is your final model. If you want to apply the linear regression means, you have to drop the newspaper. By dropping the newspaper only, you can continue. Now the interview questions after this class, now you observe. Today you observe. You'll have the what is meant by heteroscedasticity. You'll see what is meant by VAF. You'll observe what is meant by AV plots. You'll observe what is meant by with respect to influential, if the sum of the p-values are not significant, how we are going to work. What is meant by p-value and how it is going to impact on the variable significance. What is the hypothesis test involved? Now you will get all the interview questions. You will solve that all the interview questions. Now after this class, now you can check the interview questions on linear regression. Before checking is testing yourself. In the examination hall, we are not going to learn the things. In the examination hall, we are going to write the answers, and how much skill we are having, we are going to prove in the examination hall. So whoever the students have learned the concepts, if you are sure of yourself, you go and see the interview questions. If you are not sure, first practice. Before practice, first revise. Before revise, first recollect. Come step by step. It will take 2 hours, 3 hours, 4 hours or 5 hours, whatever the time, do in the proper way. Everything will be registered in your brain automatically. No need to by heart. No need to revise. No need to have the tension in the interview room. No need to check one day before, one night batting you no need to do. Nothing you no need to do. If you come in a proper way. Only thing you need to do is time. You have to give that time for your preparation. Clear, guys? With this, the multiple linear regression is completed. Yesterday, I have shown you that if there is a problem in the assumptions, what we are going to do. If there is a problem in the assumptions. In tomorrow's class, if there is a problem in the overfitting, what we are going to do, that we are going to see in the tomorrow's class. Okay, because in this example, overfitting is not there. Now we explain the same thing. In this example, only the linear regression has not met the assumptions, so I have shown you. In tomorrow's class, I'm going to show you the overfitting problem. Okay, and the same data I'm going to continue tomorrow also. I'm going to apply the polynomial regression on the same data, and I want to compare between the linear regression and non-linear regression. If I apply for the same data, what is the difference? And which is the best out of these two? And in the polynomial regression, if I get some kind of overfitting, then how to reduce that overfitting? Again, I'm going to do on the same data with one more. The entire project, what we are going to do in the real time in the company, the same way I'm going to do here. The only thing I'm missing is future engineering I'm not doing here. You are doing that one. Okay, for my students, in order to develop their subject, I'm giving that option for students to do that one. Now in this class, some of the students will say that, sir, please, you only do that one also, so that we'll observe the first time. They'll ask like this. Whoever the students are asking in that way, they say that, sir, I'm not understanding and I'm not able to apply, sir. So tomorrow in the company also, the first project, the person has to explain for you, right? Step by step, he has to take one slate and one pencil and he has to explain everything. Okay. So while going to tomorrow office also, go with instead of going with a laptop bag and all these things, go with a slate and a chalk piece. They will teach you how to write each and every letter. Right? Sorry, using VIF test. Okay, done. Yes. Out of, if you observe this VIF within this, which is the highest one? From here also, it is clearly indicating that it is having high impact on others. Na? But how more than 4 only, here it is saying this particular thing says that more than 4 only, remove that one. Each person has told in a different way. Each approach in a different way. Yes. So no need to remove as per VF. As per VF, you should not remove. You have to apply everything. First, you have to check influential plot. You have to apply this one. You have to apply that one, this one, that one. Anything you have to apply. There is no question which to apply. If you ask the question which to apply, means answer is all to apply is the answer. Nothing like that. Some use this one as the best, some use that one as the best. For example, let me explain with you a simple example once again. If you have went to a YouTube and you have loaded the linear regression, you have typed in the linear regression and you want to learn once again the linear regression. You have not paid the recordings for me. 5,000 rupees you have not paid and just you want to revise yourself. So you have went to the YouTube and you have typed in the linear regression. And that one of the, first you are going to listen one video. And he is going to explain in a different way. It's simple, like one example. One more video. Is both are going to explain the same way? Which is correct out of these two? If I ask this question to you, which is correct? The first video person is correct or second video person is correct? How you can know after seeing the second video only? If you see the third video, out of these three, who is best, miss? If you observe the third one only, you will say that which is, if you don't see this video, how you can confirm the other person is good or not? If you compare only, you can say that. Without opening that video, how you can say? That is question number 1. Question number 2. This person has explained very clearly the linear regression. But if you open that same channel, that video is very clear. Okay, nice. And immediately you have clicked on the subscribe button and a like button or whatever it is. You have done. Now you have felt that, okay, this person is explaining the machine learning very easily. Let us follow him. And you have opened the other videos also of him. One video he has explained very clearly. Other videos he may not explain. Na? He may not be that much of good at on the other videos. It is mandatory that every algorithm should be that much of good. It is not mandatory. At the same time, it is not the case that every time it is going to be false. What is the exact scenario, miss? Unless we open the other videos also, we can't judge anything. right? For example, if you want the statistics I have followed from one YouTube channel. Okay, my favorite YouTube channel with statistics is entirely different. My favorite channel with coming to future engineering is entirely different. My favorite channel with respect to machine learning is entirely different within the YouTube. Similarly, textbooks also. For statistics, I follow a different textbook. For future engineering with Python is the textbook name. The textbook name is Future Engineering with Python. Okay, let me show you. My favorite books. So I have given here some numbering for as per my choice, my numbering this one. It is not applicable for you. For you, different numbers will be there. This is as per my choice from my perspective. And here, with respect to, there is a future engineering. Na? Yeah, future engineering. This textbook is purely for future engineering. If I open, see, future engineering for machine learning, only future engineering. What is the syllabus it is going to cover, miss? How to deal the missing values, how to deal with categorical variables, how to reduce the dimensions, how to do this one. Those things will be there. This textbook, if you download and if you start learning, it will be completed in 1 day. Max 1 or 2 days. Because most of the concepts I have already explained in the class. Okay, remaining concepts we are going to see in the further. By end of the time, if by end of this course, it will be completed entire textbook, 100%. Okay, as of now, most of the 70% to 80% it has been completed. If any 10 or 20% is left out, miss, that also will be covered. Like this, we are going to cover more number of textbooks. Almost this from here, whatever the numbers I am having from 1 to 14, whatever I have written, these things already I have completed. All the textbook from starting page to ending page completed. So I'm in the next line of textbooks. I'm reading off that. Whenever I feel free time, I'm going to apply. Then according to that, I will change the numbers. As per my choice and my preparation, this is all. So what I want to explain here is, one is good, miss, others is bad, you can't come from. You have to try with all of them. That is for your answer, that is the reason. Okay. All the textbooks has been downloaded from the same website. Every textbook was downloaded from the same website, or some people are going to share on the LinkedIn. Some people will share on the WhatsApp, something. Na? Everything I have downloaded and I have saved in a separate folder. Just I have downloaded wherever I find the material. So tomorrow, one of the student shows me something. Immediately I will download and I will save in the folder. Like that. I have gathered the collection. That's it. So you can get most of the textbooks on the LibGen. If you are not able to identify, please let me know. I will share you on the drive. For me, not a problem. Sharing is not a problem. But the thing is that if I share means, you will not even check or you will not even search. In the tomorrow, in the real time, you have to search on your own. You have to identify which is the best. You have to learn of your own. More things will be self-made. So that is the reason I'm asking you to do. Why always I'm saying this one, miss? The real-time scenario will be like that in the company. In the real time, you have to be one of the best, miss. You have to be trained in such a way. Right, guys? Yeah, please go through the notes. Please go through the notes. If any questions, offline students, please.